Hello guys and welcome to Computing Fundamentals. This is our live tutorial about graph connectivity. I wish you are doing very well and you have enjoyed doing the lab in the last time. So today we are going to focus in a specific thing to study. We will study how to use Sage for representing a graph and also testifying whether a graph is connected or it's not connected. So the first thing I will do is basically to start Sage, and today there is a few tricks I want you to learn about. So this is my page, you can see it now. I have Sage on the left and I have also a text editor called Sublime. So all the code that I will do in this tutorial, you would see them inside this this file in Sublime. So I wish you could identify that and you don't have a problem in copying and pasting the tutorial. Also, there is a GitHub file that I will commit all my changes to it, so you can access it and view the command after this tutorial if you would like to see that. So you just go to GitHub and I will share the link now in the classroom page, and I will also share it to you guys in the text box. So this is the live tutorial and all the commands that I will be using in this tutorial will be posted here at real time in order for you to copy and paste, because there will be loads of writing today. Okay, so the first thing I will do is to share this repo for you so you can read it later on if you would like to get more information about how I did it and how things are working. So the repo is now available on the text box of the chat, so feel free to go and keep that URL or open it in a new page so I can start doing my business. Now back again to Sage, and the first thing I will do, guys, is to represent a graph G. So let's say I have a graph and I want to represent it. So let's say I have a graph and this graph is G, and what I want to do is basically a complete graph, just to see if whether a complete graph is isomorphic or it is not an isomorphic. Okay, now I will represent this and I just want to press run it in order to see how this complete graph look like. Now the second thing I will do after that is to testify whether this graph is connected or it's not connected. So to determine at any stage whether a given graph is connected, we just put P, which is basically the variable I use for the graph, and then I just do P is connected and I run this command. Now this will tell me whether this graph is connected or it's not connected. Now Sage is a little bit slow today, I don't know why, so maybe I have to restart the Sage server or restart my computer, but we will do that in the break. Okay, I need to wait, or I refresh the page, so make sure the kernel is ready here. These are one of the issues with Sage, so come on. P dot is P. Okay, I will create a new file. I just create a new file because I don't want to keep you waiting for nothing. So the first thing I did is just to represent a graph, and this graph will be used in order to identify this graph is connected or not connected. I execute the command. Come on, quit Sage. Give me a few seconds, guys, so I will restart Sage. I think the Sage is not responding, the Sage server. What a start today. I don't know what's happening. Like, okay, I am back again, and this is my Sage. All good. Hopefully it's all good. Hopefully. Now this is the command I wrote, the last thing, and I want to run this. Maybe I should run this again. Really? I think Sage crashed. I just do think Sage did the crash. But you have all the commands, guys, here in Sublime, so you can see what I have done. So feel free to implement them. And I will see what's going on with this Sage math today. So I will start maybe another server. Okay, so the server was not running, and that's the problem. Now just let me just do a quick test. Let's say p number of edges to make sure it's not going to give me any trouble again. So that's the problem solved now. Okay, the next thing I want to do is to create a very fantastic, awesome, well-aligned, well-formatted graph for the Irish map. It's just like a map to just explain how, for example, the roads are connected between Dublin, then to another city. Let's say if we travel by the M7, what we are going to see. Now, I know most of you, they will say, well, we don't know really the Irish map, how it's look like. So let's say I want to travel from Dublin and then to Naas using the M7, and from Naas I will go to Newbridge, then I go all the way to Portlaoise. Now, as you're going to see from this code, I make this graph with a graph plot where I can specify the title, I can specify the vertex size, and also I specify the edge thickness, the edge color, the vertex color, and the edge label, which is you will find really useful when you are doing the lab and the tutorial, because you could adjust the look and the feel of the graph. So this is my graph, and I just want to run it. If that, please run it for me, Sage. Don't put me in trouble with those guys. So you can see now I have a nice graph to represent the Irish road or the Irish path from Dublin to Naas, then to Newbridge, then to Kildare, then to Portlaoise, and it's also connecting me with Carlow with M9. Now what I want to see, and this is where we can understand the connectedness of a graph. This graph is basically a connected graph, because you can have a path from any vertex to any other vertex in this graph. Now, to testify this, all I could do is to test whether this G is connected. So once I put this command, which is G dot is connected, this is going to return to me a true or false value of the connectedness of this graph, which is basically true. So this graph is a connected graph. Now, if I wish to do, for example, if I wish to obtain or return the list of connected components of this graph, all I could do is just to put G dot connected components, and this will return to me a set of all connected components. And you will see the first element of this set here, that Carlow, Dublin, Kildare, Naas, and Newbridge are connected in somehow as an element, and we have also Portlaoise. Now let's say I want to add another edge to this graph. Let's say I just want to add another edge which is not connected. Now I just make add, a vertex, and this is will be, for example, cork. I'm not going to build any edge for this graph. Now let me just quickly represent it again, but this is, I want to represent it using my beautiful function that I just wrote to represent this graph. So I will make a new cell, and then I will paste my lovely function to represent this graph, and then I will run it. Now you can see that I have a new edge, a new vertex in this graph which is not connected to them. Now what do you think? If I just put now G is connected, what do you think? I'm going to get it true or false? Let me know in the chat box, guys. What do you think? True. Now what we could do is just to run again is connected. Once we do that, it is giving me false because cork is not connected to anyone. Now if I just want to see the connected component in this graph, all I need to do is to run the command, which is g.connected components, and now you will see that I have two elements in the list. So there is one element which is basically explaining to me that Carlo is connected all the way to Portlaoise, and you will see that cork has been isolated here alone by itself. So it's another element in the list. Okay, can you see the code in Sublime, or you can't see it? You look like you can't see the same file I'm using. So I will go back and just make sure that you are seeing what I'm seeing. I'm sorry for that, guys. Like, I don't notice. Now you should be able to see the code as I do. So you should be able to see all the code that I just wrote in this tutorial, and I will also update the GitHub with the new content while I just give you a few tasks to do. Okay, do you have any questions so far, guys, about this? Okay, so now you can see the content of my file. Okay, all good. Do you have any question? Yeah, just go and ask me before I start with doing the next thing. All right, so all good. So all the commands, you can see them, because I will write now like today there will be a heavy coding, and for this reason I hired an agent for me, so you'll see me not typing, but there is code, somebody typing code in the screen. So don't worry about it, don't be freaked out. It's an agent, it's a micro running at the background, just doing the typing instead of myself. Now the next thing I will do is I go back to Sage and I will create a new cell, and in this new cell I want to return the subgraph of a strongly connected component by an example, and I will give you like an example of this thing. Now my micro is just decided to go haywire, so let me just do a quick refresh for this and then ask the guy to type for me again. So I will create a graph, which is graph G, and G is basically where we have a vertex 0 going to 1 to 3, 1 is going to 2, and 2 going to 3, and 4 is going to 5 and 6, and 5 is going to 6, and so on. Now what I want to do is to return back if G is a connected component of subgraph. So I will store the connected component as a subgraph in a variable called L. Now I want to show this L, and I need to run this in Sage. All right, so I have this keep changing, so I will okay, use the magic trick, control copy, control paste. My Sage is so slow today. I will take like I will give you some break, guys, until I manage to restart my computer. Even I cannot show you the lab sheet, which is unfortunate. Okay, if I go back now after a long time of waiting, I can see now how are the connected component of my graph. But maybe you just say, well, Basil, I don't know how the graph look like, so let me print the graph first. I need to restart my computer, definitely. I need to start from scratch. Okay, I will just put it here as a new cell, and then I will delete any string characters, putting in the background. It's running, but it's so slow. So this is the graph that I was representing there, guys, and now you can see those are the connected component, the subgraph of, like, those are the subgraph of the strongly connected component, as you can see, which is basically the element here in the left, which is the graph which basically have a path from any vertex to another vertex, and we will have also another path from vertex 5 to 6 and to 4. Now, as I am expecting, you should be able to see the commands that I wrote, so you should be able to copy and paste that straight away. Now, while I will go now to restart my laptop, and I want to come back and do some amazing things. I have like a long script for you to do. I have the code ready for you, so you don't need to worry about it. All I want from you guys for today is I want you to do this task. Now, you have the lab sheet. Now, let me just go to my courses pages and just see where I could find the lab that I just posted for you. Now, this is your course and your class page, and this is where I just put it. So while I'm doing this restart, which will take like 5 minutes until I manage to put everything in place, I want you to go and use Sage to represent the following pairs of graphs. So do the first one, the second one, and the third one. Now after that, just try to make sure check each graph is connected or not, and then try to use or to return a list of connected component as a graph object. Now, as I go back, once I go now, I want you to see this list of interesting and very useful commands that you can use with connected and unconnected component. So I will just put it now in the screen so you can see it, all of you. So connectivity. So this is a table with all connectivity methods available in Sage for you guys just to use straight away. All right, so this is a list of all connectivity. Do you have now an access to, or can you see the page where it's give you a list of all connectivity methods? Okay. Your task is to create the first 3 graphs using Sage. Okay, take like 10 minutes, no rush, and then try to check whether they are connected. Is this, for example, is it strongly connected? You can ask, or you can use this method as well, and then check the connected or the strongly connected components in the subgraph. What I will do, now, yeah, because I put all the code there. It's already there. The code, I think, is already there. Can you see all the code, guys, in GitHub? Let me double check. Everything in my screen is like very slow and delay. It is empty. Okay. I will update the code now, just when I come back. But can you see the code now in front of you in the screen? Can you see the code in Sublime? Okay, I will just update it, the GitHub file. Just one sec, I will do that. It should not be. Okay, let me do it the old-fashioned way, because there is loads of typing today, so I don't want to lose any time.